Alright, topic 2.3. We'll be talking about segments and distance. We've already learned a little bit about a segment, what a line segment is. Now we're going to talk about determining the distance between the two endpoints of a segment. So let's get to first page of our notes. It has line segment, and it's after a definition which we have already looked at in the past. A line segment is part of a line consisting of two endpoints. Two endpoints. And all the points between them. That's the definition of a line segment. So, let's look down in your notes. It says to measure the length of a segment, because that's what we're going to talk about with the distance. The distance will be the length of a segment between 2 points. It says you can use a number line to find the distance between two endpoints, or you can use the formula. And here it gives us a formula. It says D on the number line equals. So we've got D equals. And when we're looking at the distance, we're going to look at the absolute value of A minus B and close my absolute value. And if you look down below that, we're going to look at example 1. Example 1, it says find the distance between -2 and 6 on a number line. Now if we don't actually have the number line here in front of us, well, we're going to look at this, and it doesn't matter which order you put it in. That's why we have the absolute value. So let's put this, the absolute value of -2, let's call that the A, minus 6. And you know what, here, let's do this to keep it similar to right above us. -2 minus 6. And then also, let's look at it the other way. It didn't pick up my color there. We've got an absolute value. Once again, didn't want to pick it up. There we go. The absolute value of, and we're just going to switch to order, 6 minus -2. Now make sure that whenever you write this, that you're paying attention. This is a -2, so 6 minus, and then your -2. Alright, so let's do this first one. Let's do the math on it. -2 minus 6 equals -8. We have the absolute value of -8, which is 8. And now let's look at our other one over here. We've got 6 minus -2. That is going to turn into 6 plus a +2 when we change the sign of that, which will give us an 8. We still have the absolute value of 8. And whenever you bring that out, your answer will be 8. I'm going to leave example 2 to you. You can do this formula in between on the dotted lines, finding PQ and Q and R. You can also count to double check. I would really prefer that you use this method on example 2. Alright, moving on to the second page of the notes. It says when a line segment is drawn on a coordinate plane, you can find the length using the distance formula. Now whenever it's talking about on a coordinate plane, we have, you can write this down off to the side. It's talking about solving for x1 comma y. You know, I'm just going to go ahead and make this yellow. x1 y1. You have that. That's one coordinate. And you also have another coordinate, which we're going to define as x2, y2. So that's what we have. We have 2 points on the coordinate plane, and then you can draw a line segment between those 2 points. But in order to solve, you use the distance formula. D equals, we have the square root. We've got quite a bit underneath the square root. Square root of, open up some parentheses here. Let's see, find a color that'll go with that. And we're going to take x2, we're going to subtract x1, x2 minus x1, and then we're going to add to that y2. Actually, before we go off and get that x2 minus x1, we're going to square that value. x2 minus x1 squared plus y2 minus y1, close parentheses, and this is also squared. Oh, did not grab my right color there. Let's undo that. Squared. Alright, so the distance formula. This is on a formula chart, just in case you take a test with that. But our distance formula is the square root of x squared minus, or x2 minus x1 squared plus y2 minus y1 squared. Now let's use this distance formula with example 3. Example 3, it tells us to find the distance between, and here it gives us our 2 coordinates. I'll write this down, our 2 coordinates. It gives us 2, -1, and then it also gives us -2, -1, -2, -1. Alright, so there's our 2 coordinates. We're going to use this. This will be our x1. This will be our y1. This will be our x2, and this will be our y2. We simply plug that in to our formula. So D equals, we've got the square root. Now I'm going to substitute in what we have here, our parentheses. First thing is our x2. Our x2 is -2 minus our x1, which is 2. And that did not grab my color for that. Here we go. 2. That way we can keep it separated here. We've got that number. We're going to square it. We're going to add it to, we've got y2 minus y1 squared. So y2 is -1 in our case, minus our y1, which is another -1. Put that on there. Let's put the correct color here, and we're going to square that value. Alright, so for this next step we're going to actually solve what's in the parentheses. We have our D equals, we're going to keep our square root, and now let's solve here in these parentheses. We have a -2 minus a 2, a negative minus a negative, which is going to give you 4. Put this in parentheses because we're still going to have this value. We're still going to have to square it. Plus, now what's a -1 minus a -1? You turn this positive So negative 1 plus 1 will give you 0. Go ahead and close my parentheses and rewrite our equation. Okay, so now that's what we're looking at. Now let's look at our next step in solving. D equals square root. And let's look. Right now, a lot of you might think, well, let's go ahead and pull these out. Well, you have to add these two together. You actually have to square them and add them together, then take the square root. You can't just go ahead and take them out of the square root and cancel the squared yet and then add them together. That will not get you the correct answer. For our first steps, we have to square this. We have to square this one, and we have to add them together and then take the square root. So if we're looking at this, we've got 4 squared, which is 16. Now this just happens to work out this way because of this problem. 16 plus, and then obviously 0 times itself is a 0. Snag this color here. A 0. Alright. And finish on, we can say the square root 16 plus 0 is 16. So our distance is going to equal, I'm going to bring it over here, distance is going to equal the square root of 16 or 4. And that would be your final answer. Use that on example 4. We're also going to use the distance formula. The only thing is now you have an actual graph. You have a graph there that's got 2 coordinates and a segment in between it. You have to find the 2 coordinates. There's a hint for that. You have to find your x1, y1, and your x2, y2. It does not matter which one it is. You've got an A and a B. B could be your x1, y1. A could be your x1, y1. The other one has to be your x2, y2. Does not matter the order. So go ahead and work that one, and then we will continue on to our example 5. Alright, moving on with example 5. Right up above example 5 on the 3rd page, it tells us, it says, examine the measures of PQ, QR, and PR from example 2. Notice that if you did your distances and get your correct answers, PQ will equal 1.5, QR will equal 4.5, and PR, which is the outside of the 2 of those, equals 6. And it tells us here in this, it says, notice that 1.5 plus 4.5 equals 6. So we can say, and this is for that blank, we can say that PQ plus QR equals PR. Make that R a little bit neater there. PR. This suggests the following postulate, and it tells us down below, segment addition postulate. If Q is between P and R, then PQ plus QR equals PR. If PQ plus QR equals PR, then Q is in between P and R. Now, one thing that it's a key note that you need to write or think about, maybe even possibly write down, is it says if Q is between P and R. In our case, if you look up above it, it does not mean it's going to be in the exact middle. It's just somewhere in between. The 2 distances will add up to the total distance of the outside points. So, let's look at example 5. Example 5 says if B is between A and C, and AB equals 4, and BC equals 5, then AC equals blank. So, using this postulate, I'm going to put here AB is equal to 4, and BC is equal to 5. I forgot my C there. BC is equal to 5. Then it's going to ask us what AC is. If we drew this out, if we would actually take a line and we were to draw this, there is our number line or our segment. I'm going to put points. Let me put some points that are pretty well defined. That's not going to be in the middle. It's going to say A, B is equal to 4, so we know that this distance right here is 4. BC is equal to 5. Now it wants to know what AC equals, and our answer to that is if you add these two together, you will get 9. That is 4 plus 5 equals 9. So work example 6. And example 6 will be very similar to example 5. You'll use the same thing we had at the top of the page. Once you get finished with that, we'll go ahead and work example 7. Example 7 may help you with example 6. It's going to be very similar, except there's probably going to be a few more steps actually in example 7. So example 7, let me pull it up here. It says find LM. So we're looking for LM. I'm going to put a little question mark. This is what we're trying to find. Find LM if L is between N and M. And then it gives us NL is equal to 6x minus 5. 6x minus 5. LM is equal to 2x plus 3. 2x plus 3. And lastly, it tells us that NM is equal to 3x plus 13. Plus 13. Alright, so I'm going to go ahead and I'm going to draw our line, our number line that we've been working with. For a visual aid, there's a number line. I'm going to put points on this number line. I'm going to put a point here, somewhere in the middle. It really doesn't matter if it's in the middle or not, for the sake of visual aid here. This will be our point N. This will be L. This is M. So now we have it drawn correctly. It says L is between N and M. Now it tells us that NL, this right here, is equal to 6x minus 5. This is equal to 2x plus 3. And then it tells us this whole thing here, this whole portion here, is equal to a 3x plus 13. Now I'm going to look back at the top of the page, and it's talking about example 2, and it shows us PQ plus QR equals PR. So if I was to rewrite this for this equation, I would write an NL plus an LM is equal to an NM. Now I'm going to substitute what we know for these. There's a visual of it. So let's substitute NL. We're going to write 6x minus 5. Now we're going to add LM. LM is 2x plus 3. We're going to set that equal to NM, which is 3x plus 13. So now, all that aside, now we just have an equation where we're going to look to firstly solve for x. Now that's not going to give us our answer. That will give us what our variable x is equal to. So first thing I'm going to do is I'm going to combine like terms. I'm going to combine our x's, and then I'm going to combine our other numbers here on the side. Our x terms will have, pull out my color, 6x and a positive 2x and 8x. We have a negative 5 and a positive 3. Well, that will leave you with a negative 2. We're going to subtract the smaller from the larger and keep the sign of the larger. Negative 2 is all equal to a 3x plus 13. Now, I'm going to move my x's to the left side and my numbers over to the right side. So if I have a positive, subtract a 3x here, subtract a 3x here. You can do this all in the same step or different steps, but here we have a negative 2, so I'm going to add 2 to both sides. Now whenever you work this, you will get 8x minus 3x is 5x is equal to, we can look at these and we can say, well, this will cancel itself out, this will cancel itself out, and what we're left with over here is 13 plus 2, or 15. 5x equals 15. Divide both sides by 5. X is equal to 3. Now, this is not your answer. What the question asks for is what is LM. So we have to take this x, we now know what the variable x is, and we have to plug it in. We have to take this number and we have to plug it in to our equation for LM, our x. We know that LM is equal to, I'm going to rewrite it over here, 2 times an x plus 3. Now I'm going to substitute in 2, and now we have a times 3, because we know what that is now, plus 3. 2 times 3 will give you a 6, plus a 3, 9. So our final answer is our LM equals 9. Put a box around that, that way we know exactly where your answer is.